Welcome back to our DSA series. Today, we're exploring an essential data structure, queues. If you're ready to dive deep, stay tuned. Queues are a fundamental data structure in computer science that operate on a first-in, first-out principle, often abbreviated as FIFO. Imagine waiting in line for a movie ticket. The first person in line is the first to get served. In programming, queues are used for scenarios where order matters, such as managing tasks or handling requests. Let's start by declaring a queue in C++. The Standard Template Library, or STL, provides a queue class that makes this easy. We include the queue header and then use queue to create a queue that stores integers. Now, let's look at the basic operations. The push operation adds an element to the end of the queue. It's like adding a new person to the back of the line. Here, we push 3 elements onto the queue, 10, 20, and 30. The first element, 10, is at the front, and the last, 30, is at the back. Next, we have the pop operation, which removes the front element from the queue. Think of it as the first person in line getting their ticket and leaving. Here, 10 is removed from the queue, leaving 20 and 30. Now, 20 is at the front. To see what's currently on top of the stack, use the top function. This operation doesn't remove the element. It just returns its value. Here, front element holds the value 20 and back element holds 30. This is useful for inspecting the queue without modifying it. You can also check if a queue is empty using the empty function, which returns a Boolean. This code checks if the queue is empty. If it's not, you can continue working with the elements inside. Queues are incredibly useful in various applications like task scheduling, handling requests, and even in algorithms like breadth-first search, BFS. As a sneak peek, queues are key to implementing the BFS algorithm. We'll cover BFS in more detail when we get to graphs. In BFS, the queue helps to explore nodes level by level, ensuring each level is fully processed before moving on. In this flowchart, Step 1, start of the BFS algorithm. Step 2, initialize the queue and visited list. Step 3, enqueue the start node. Step 4, check if the queue is empty. If no, proceed with the BFS. If yes, end the algorithm. Step 5, dequeue a node. Step 6, process the node, e.g., print or store it. Step 7, enqueue all unvisited neighbors of the current node and mark them as visited. Step 8, end of the algorithm. Queues ensure fair resource allocation and are easy to implement. However, like stacks, they don't allow random access to elements. And that's everything you need to know about queues in C++. They're simple, efficient, and widely used in both basic and advanced programming scenarios. If you enjoyed this video, make sure to give it a thumbs up, subscribe, and hit the bell icon to stay updated with our DSA series. Practice questions on queues on any of platforms that you like to have a strong command on them. Thank you for watching.